Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 class. Today we are going to wrap up Chapter 3. We're going to talk about 3-6. We're going to learn about arithmetic sequences. And an arithmetic, well, any sequence is an ordered list of numbers that often form a pattern. They don't necessarily have to form a pattern, but for the most part, when we have sets of numbers that are ordered, they usually form some sort of pattern. And this pattern is the sequence. Every number in the list or in that pattern is called a term of the sequence. Okay? There are two different types of sequences. There's an arithmetic sequence, and an arithmetic sequence occurs when you add the same value repeatedly. Now that value that you're adding, it can be positive, it could be negative, it could be a fraction, it could be a decimal, it could be a mixed number, it could be any kind of number, but you're adding that same value over and over and over again, repeatedly. A geometric sequence is a sequence in which you multiply the same value repeatedly, whether it be a positive or a negative or a fraction or a decimal, any real number. You're adding that real number's value repeatedly. I'm multiplying it repeatedly for geometric. Today, we are only going to focus on arithmetic, but I wanted to show you that there are two types of sequences, arithmetic and geometric. So let's get to it here, guys. Before we formalize the arithmetic sequence, let's see if you guys can just start recognizing patterns, okay? For these here, describe the pattern in each sequence. What are the next two terms of each sequence? So how would I describe this pattern? Yes, sir. Well, not just plus 3. I'm starting with 5 and adding 3 repeatedly, right? Because 5 plus 3 is 8, plus 3 is 11, plus 3 is 14, correct? So what would my next two terms be? 17 and 20, great. How would I describe the pattern for B? How would I describe the pattern for B? Yes, sir. Start with 2, and you're adding 3 repeatedly, yes. Adding 3 makes it work, so what are my next two terms? 14 and 17, very good. What would my pattern, how would I describe my pattern for C here? Yes, sir, my man. Start with 5 and add 6 repeatedly. Yes, it works here. Yep, it's working. So what are my next two terms? 29 and 35. Very good. Okay, my next term, my next sequence, D. How can I describe this sequence? Yes, sir. Okay, I'm subtracting 200. Well, minus 200, that works. But wait a second. What's 200 minus 200? 0. So this does not work. So this is no sequence here. Okay, it's not arithmetic. It's not a sequence right now. Yes, sir. And actually, you know what? I shouldn't say that because maybe it's a different type of sequence. This is just not arithmetic. Because you're not repeating that same value over and over by addition. For E, how would I describe this? Yes, in this case, you start with 2 and you multiply by negative 2. Negative 4 times negative 2 is 8. Negative 8 times negative 2 is negative 16. What will my next two terms be? 32 and negative 64. Absolutely. Perfect. That's not arithmetic either. That's geometric because I multiplied the same value over and over. And last but not least, how would I describe this sequence here? Yes, sir. Start with negative 15. Good. And you're adding 4 repeatedly. Very well done, son. Very well done. So what would my next two terms be here? 1 and 5. Very good. So, I'm very impressed. You guys can recognize these sequences pretty easily. I like that. I'm very proud of you. Now let's go ahead and formalize it, and then let's learn an equation so that I can show you how to find any term number in any sequence with just a series of a couple addition and subtractions. In an arithmetic sequence, my friends, the difference between the consecutive terms is constant because I'm adding the same value over and over and over and over and over. So the difference between these two numbers is always going to be the same. And this difference, since it's the same for all of them, is called the common difference. And a nice, easy way to find the common difference, which we'll call D, we'll call common difference D. The common difference is easy to find. It's simply the second term minus the first term. Second term minus the first term. Literally, that's how you find the common difference. So for our examples here, I want you to tell whether the sequence is arithmetic, yes or no. And then if it is arithmetic, what is the common difference? And I'm going to go ahead and find the next two terms. Yes, sir. Yes, sir. You have a question? You wanted to do the first one? Yes, sir. You got it. Thank you. Okay, my man. So remember, common difference, second term minus first term. So what's my potential common difference here? 5. 8 minus 3 is 5. Yes, that's potential. I say potential because I got to test it. I got to make sure that it's the same for all of them. So 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. So this is arithmetic for sure. My common difference D is 5. And what are the next two terms here, gentlemen? 23 and 28. Awesome. Great. Okay, next. What's my common difference or my potential common difference? That's right, 9 minus 6, which is 3. Does it work? 6 plus 3 is 9, but what's 9 plus 3? 12, not 13, so no, this is not arithmetic. Very good, gentlemen. Very good. Letter C. What's my potential common difference here? Yeah, 15 minus 8 is 7. Excellent. 8 plus 7 is 15. 15 plus 22 is 15 plus 7 is 22. And what's 22 plus 7? 29. That's not 29. So this is not arithmetic. Okay. How about my next one? D. What's my potential common difference? Yeah, 9 minus 7 is 2. 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 2 is 13. So this is arithmetic. My common difference D is 2. And my next two terms would be 15 and 17. Fantastic. Okay, for E, what's my potential common difference? Very good, guys. 4 minus 10 is negative 6. Remember, when we have opposite signs, you're going to subtract as normal and keep the sign of the largest absolute value. So 10 minus 6 is 4. 4 minus 6 is negative 2. Negative 2 minus 6 is negative 8. What are the next two terms, please? Negative 14 and negative 20. So this is arithmetic. And my common difference D is negative 6. Excellent. And last but not least, what's the potential common difference here for F? Sir. No, not negative 1. Negative 2 minus 2 is negative 4. That's the potential. 2 minus 4 is negative 2. But what's negative 2 minus 4? Negative 6, not 2. So this is not arithmetic. Does that make sense, gentlemen? Yes. You promise? Yes. Okay. So it's pretty easy. You subtract the second term from the first term to find your potential common difference. Then you test that common difference. If it works, bingo, you got it. If it doesn't, got to go back to the drawing board, okay? It's not arithmetic then. Okay, now, I'm going to teach you how to find the nth term of an arithmetic sequence. By nth term, it's any number. Find the 5th term, or the 20th term, or the 100th term, or the 1000th term, or the 347th term. Nth term just means any number you want, okay? The way this formula works, a to the n at the bottom, that's called a subscript. These are just labels. They don't mean anything mathematically except for a symbol, okay? So a to the n, that's the nth term. That's the term that I'm looking for. That's the value of the term that I'm looking for. So this is the nth term value, let's say. That's the actual nth term value. That's the value of that particular term we're looking for. A to the subscript 1 is the first term of the sequence. First term of the sequence. N minus 1. The n here is the actual term number I'm looking for. I'm looking for the 40th term number. That's my n. And D is common difference. Okay, D is my common difference, which we already talked about. And you find the common difference by taking the second term minus the first term. Is everyone kind of with me so far? Okay, let's put it into action. Let's see if I can make this better for you. An online auction works as shown below. Write a rule to represent the bids as an arithmetic sequence. What is the 12th bid? Okay, let's focus here. They want the value of the 12th bid. So they're looking for A subscript n. That's going to equal, A1 is my first term. What's my first term here? Guys? 200. Very good. That's my first term. Plus, n is the term number I'm looking for. What term number am I looking for? 12 minus 1 times the D common difference. How do I find my common difference? Second term minus first term. So that's 10. So my 12th term's value is 200 plus 11 times 10, which is 200 plus 110. So my 12th term, or my 12th bid's value in this case, is $310. Now, you could have just said, okay, 200, then add 10, then add 10, then add 10, then add 10. You could have done that 12 times, and I promise you get the same answer, but that's all well and good, except when they tell you, find the 80th term. And then you're not going to do it for 80 times. Not because you can't, but because it's just going to take so long. And you have a lot of potential for making mistakes there as well, guys. Okay? You have a lot of potential for making mistakes if it's a very long series or sequence that they want you to figure out. You guys with me so far? Okay. Now, let's continue. A subway pass has starting value of $100. After one ride, the value of the pass is $98.25. After 2 rides, its value is $96.50. After 3 rides, its value is $94.75. Write a rule to represent the remaining value on the card as an arithmetic sequence. Give me one. Okay, guys, sorry about that. All right. So when we're going to start a word problem like this, I don't want you to freak out. I want you to write what you were given, guys. So what were you given? You were given the following sequence: 100, 98.25, 96.50, 94.75. I want to find the value after 15 rides. So I want to find the value of the 15th after 15 rides in my car. What was my initial value? What is my A1 here? 100. Excellent. Plus N. What is my N here? 15 minus 1 is 14 times D. Now, this is what got a lot of people. What's my common difference here? Negative 1.75. Remember, it's the second term minus the first term. Remember, when the signs are different, you subtract as normal and keep the sign of the largest absolute value. So that would be 1.75. You're right. But there's more negatives than positives. So that'd be a negative. So you'd have here negative 1.75. You with me here, kid? Thank you, my brother. No. You're human. You live and learn. Good job. Now, when I go ahead and plug this in, my friends, it's going to give me the value of my 15th card, oh goodness. The value on my card after 15 rides will be $75.50. Okay? Now, not a sequence question, but a logic question. How many rides can be taken then with a $100 pass? How would I try to figure that out? Divide what? Thank you, guys. If you put $100 in the card and each ride is $1.75, if I divide, I'm going to get 57.14 rides. I can't have 0.14 of a ride. So how many full rides can I have? 57 rides on that one pass. This is everyday math, my friends. It wouldn't be 60 though, because you wouldn't have enough. You wouldn't have enough for 60. You have enough for 57.14. Good estimate, but yeah, the exact's 57. Okay, now, let's find the indicated term of each arithmetic sequence. I want the 22nd term of this sequence. So I'm looking for my 22nd term value. That's A of 22. That's going to equal A1. Remember, we're working with the following formula. The value of my nth term equals my first term plus the term number minus 1 times the common difference D. What is my first term here, A1? 5. Very good. Bless you. Plus N. What is my number, the term number I'm looking for? 22 minus 1 is 21 times D. What is the common difference here? Negative 3. Very good. Why negative 3? 2 minus 5 equals negative 3. So now it's just math. 5 minus 63, that will equal negative 58. That will be the value of this sequence's 22nd term. Does that make sense? Sometimes, especially on the SAT, they just want to make sure you know the formula. So they give it to you Mickey Mouse style. They want the 15th term, but they give you A1 and the D. Well, in that case, the value of my 15th term equals 7 plus N, which is 15 minus 1 times D of 3. So that's 7 plus 14 times 3. 3 times 14 is 42 plus 7 is 49. So the value of my 15th term is 49. You guys with me here so far? Okay. Excuse me. Each time a truck stops, it drops off 250 pounds of cargo. After the first stop, its cargo weighs 2,000 pounds. So that's what we're starting with, 2,000 pounds. Okay? How much does the load weigh after stop number 6? So let's think about this. I want to find the value of the sixth stop. What's my first term? 2,000 plus 6 minus 1, n minus 1, so that's 5, times what's the common difference here? If it drops off 250 pounds each time? Negative 250. Very good. So this is going to be 2,000 minus, because 5 times negative 250 is negative 1250. So the amount of weight after the sixth drop is 750 pounds. Sir, my brother. Okay, the question here. Couldn't I have easily said 250 times 5? That's what I did do. And then I subtracted it from 2,000. No, but you need the sequence because that was nice and easy because it was 5. What if it was 48? It's going to be a little bit more difficult. Now, you could have just gone 2,000 minus 250 minus 250 minus 250 minus 250 minus 250. And you would have gotten to 750 as well. But it's easier to put it into a nice, neat formula. Does that make sense, son? And yeah, and that's it. We're done. Any questions at all, my friends? Yes, sir. Any other questions here? Okay, thank you very much. I hope you learned a lot and have a great day.